Did you hear about Elon Musk and NASA's new engine? It's a light-speed engine, faster than anything in the aerospace industry. It's taken years of research and development, but it's finally here, and the meteorite test showed its capabilities. Some scientists disagree that this new light-speed engine for interstellar travel is an exciting development. Several challenges are associated with space travel and a mission to Mars, the fourth planet in our solar system. Elon Musk plans to make it possible for humans to travel to Mars by 2050. Since Elon has proven to be productive in the past, NASA is teaming up with him to achieve their goals. To reduce expenditures at launch, developing a game-changing engine in-house is necessary. A small group of NASA engineers has tested what's being called a new rocket engine that can run considerably more efficiently than anything currently found on Earth. NASA and Elon Musk think it's a great development. Why? Spaceflight could soon become much more accessible and affordable thanks to a newly tested engine developed by NASA. Most commercial and military rockets today require chemical fuels, which must be manufactured on Earth and fed into rocket boosters before takeoff. Costing a lot of money and effort, this method is also limited in the amount of weight it can remove from the ground. That brand new engine in the lab, it's powered by regular old household electricity, which you connect to a wall socket. The idea may seem outlandish at first, but it seems more reasonable when you consider that energy is used in nearly every aspect of your daily life, from powering your vacuum to turning on the lights. To get to Mars, which is on average 140 million miles from Earth and would take a rocket flying 15,000 miles per hour for at least 7 months. The fuel must be prepared and loaded aboard the rocket before it leaves Earth to ensure a successful flight. There are many considerations when designing a rocket to undertake such a difficult journey, and the answer is a lot. When designing, it is crucial to balance the spacecraft's mass and fuel efficiency. But what kind of storage space and fuel capacity would be required for a rocket that consumes 11,000 pounds of fuel each second? At 120 meters in altitude, the spacecraft's 33 Raptor engines can withstand a thrust of 500,000 pounds. Despite the engine's efficiency, obtaining sufficient fuel for a voyage to and from Mars will be difficult. If you were to take a closer look at the current Starship for the one-off trip to Mars, you'd notice that most of the craft's weight is allocated to fuel and supplies, leaving the astronauts with only a tiny fraction of the space. This explains why all previous missions to Mars have been robotic expeditions utilizing lighter rockets. There was no need to bring along astronauts, who would have required more fuel and supplies. Even as forward-thinking as he is, Elon Musk recognizes the challenges ahead, warning that such a trip would be dangerously crowded, laborious, requiring additional fuel added to an already hefty vehicle, and expensive nonetheless. When a new engine is developed, chemistry is frequently the key to unlocking its full potential. Rockets are based on the third law of motion, which states that the action and reaction forces must be of equal magnitude and opposing direction. The current Starship design and the Falcon 9 space shuttle lend credence to this idea because they rely on thrusters for propulsion. The hot exhaust that combines fuels like methane and oxygen in a combustion takeoff can be accelerated by using a nozzle to channel steam and water. Objects get more cumbersome as they approach the speed of light. However, the purpose of this light-speed engine is to subvert long-standing norms. It can travel without using any propulsion system, as general relativity requires. The engine accelerates ions to moderate speed in a closed loop to generate thrust, and then slightly alters their velocities to cause a net change in the ions' masses. The engine will have a spiral shape, much like a stretched-out thread, and will operate only on the back-and-forth movement of ions trapped within electric and magnetic fields. This light-speed engine hopes to generate push without fuel with a continuous electromagnetic drive. As David Goodwin has noted, suppose the vibration from the electromagnetic or ionic fields is channeled in one way. In that case, any rocket can be launched faster and farther into orbit than any propulsion system ever deployed. It could eventually perfect a propulsion system so efficiently that it can reach speeds within a fraction of the speed of light. The concept of propellant-free propulsion is not new. In 1990, Goodwin oversaw a NASA project that made significant strides in propulsion physics on the path to creating such a mechanism. The first working prototype of a reactionless drivetrain was built in 2001 by Roger Scheuer. If the innovative light-speed engine can allow humanity to probe the cosmos, why are scientists against it? Since the first presentation in 2001, scientists from the UK, the US, and China have demonstrated exactly how electromagnetic propulsion would function. However, skeptics argue that this is no cause for celebration because it is unsure how the engines would be used in practice, as the earlier tests were not conducted in a vacuum. If deemed significant, these experiments detect a small effect of the device that could lead to measurement errors and ambiguity well before the project can even get off the ground, because you can't ionize particles in a quantum vacuum and thus cannot generate power. Using an electromagnetic EM drive would require extensive study and come at a high cost, which we must consider. NASA has already given it $5 million. And it's impossible to say how much more will be needed to finish the engine. This engine attempts to overcome the law of conversion of momentum, which stipulates that an object's velocity stays unchanged without any outside force by creating momentum without catalysts. Since momentum conversion is already well established in physics, it is unlikely that this new engine will defy the laws of physics, which hold for all currently known kinds of motion. Elon Musk and NASA will undoubtedly have to use their resources to improve the engine. One cannot ignore the possibility that it could be used to fly to space one day. When completed, it will have one of humanity's greatest steps toward evolving into a multi-planet journey. However, when it comes to bringing science fiction into the real world, Elon Musk is one of the leaders. To defy the laws of physics, his business, SpaceX, claims to have developed and successfully tested a new type of thruster. A velocity of 65 kilometers per second, or around 135,000 miles per hour, is possible with the rocket's electrically charged gas propulsion technology. Cold gas thrusters and fuel tanks constructed of ultralight carbon fiber power the engine. According to Wired, the engine does not use combustion to generate thrust, but accelerates superheated plasma using magnetic fields. Since no propellant is used, it does not contribute to space pollution. Electric thrusters are what these engines are, although they operate considerably different from the ones employed in SpaceX's Falcon 9 rockets. Pressured gas generates thrust, while electricity thrusters use plasma that generates ions to move a spacecraft. SpaceX's electric engine has the potential to power manned trips to Mars and beyond, and it is said to be more powerful than traditional gridded ion thrusters.